All right, I really hope this works where everyone can see. Let's do some math here. So these are the numbers from our example in the textbook. If you have no idea what numbers these are, go back and watch the video before this one. Okay, so remember, when we were calculating z-scores for individuals, we were using the formula z equals x, the individual score, minus the mean divided by the standard deviation. Okay, and remember, for this, we're doing something very similar because we're still looking for a z-score. What we're doing now, you've seen the formula in your textbook, and we've discussed it here, is we're doing z equals the mean of our group we're interested in looking at, right? So the students who had the information before seeing the picture, minus the population mean, so all the students in general, and this whole thing is going to be divided by the standard error. Now, part of this we can go ahead and fill in, okay? So let's move our z down here. We know the mean of the students we're interested in, right? It's 220. That was the average attractiveness rating after they were told, oh, hey, she's also a good person. So we can put in our 220. We also know that the population mean of all the other students when they did this test without being told any information before being shown the picture. And that was 200. So we know that this first part right here is this. Now all we need to do is figure out the standard error so we can divide by it to find our z. How do we find the standard error? Remember, it's in your textbook where you find the variance first, or I gave you the alternate formula up on the board that, let me move where you can see here. There we go. That standard error is going to be equal to the standard deviation of the population, symbolized by this lowercase sigma, divided by the square root of n. So we're good because we know both these numbers, right? We know that the standard deviation of the population is 48. Square root of n, we know that we're going to be looking for the square root of 64. Square root of 64 equals 8, right? 48 divided by 8 equals 6. So we can take the 6, which we know is this standard error, right? We take this 6 and we plug it in down here. So we do our math. We get 20 divided by 6, because 220 minus 200 is 20. We get 20 divided by 6. So we get 3.33. Feel free to use a calculator, use Excel. I don't expect you to do this in your head by any means whatsoever. And from there, your textbook does give a very clear example of how to take this, plug it into your tables, and determine if this was a statistically significant result. I want you to try to do example 2 before watching my video for it to see if you have the hang of it on your own.